Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zikroikar from BETE FJW, and today I want to present about semiconductor. Semiconductor can be considered as one of the most important inventions of all time. So they are foundational to our ability to connect with each other, to collect, store, and process information, and to implement intelligent automation, also referred to as chips as for short, or integrated circuit IC. Semiconductor have transformed entire industries such as entertainment, retail, medicine, and agriculture. So first we go with electron and hole. So one of the two types of charge carrier that are responsible for creating electric current in semiconducting materials. And holes can sometimes be confusing as they are not physical particle in the way that electrons are. Rather, they are the absence of electron in the atom. Both electrons and holes are vital to the creation of current in semiconductor. Under the influence of some external voltage, both electrons and holes can move through a semiconducting material. So secondly, we go with parameter and adjustment conducting. So on the planning part, we have model conditioning. So on the model conditioning, we will simplify and the model structure, determine of parameter for adjustment. And second, we go with parameter analysis, determine of input value for stimulation, and measurement values and location. Number three, we go with procedure planning, design of load and measurement regimes. So on the experiment part, we go with stimulation and measurement. So on the stimulation and measurement, we will conduct a load of tests and measurement. And number five, data preparation. On the experiment, we always have a data preparation on conditioning of fetching and measuring data for the material that we used. And the third one is optimization. For the sixth step was parameter identification, non-linear optimization of parameters, and seven, result verification, that control measurement. So on semiconductor also, we have a crystal structure. So crystal structure is in most inorganic substance form. There are atoms or ions into an ordered array known as a crystal. In crystallography, crystal structure is a description of ordered arrangement of atoms, ions, or molecules in a crystalline material. Most metals and alloys crystallize in one of three very common structures: body-centered cubic (BCC), hexagonal hexagonal closed pack HCP, or cubic closed pack CCP, also called face-centered cubic FCC. A semiconductor crystal is built from copies of this unit cell, Si, Ge, and C diamond, form interleaved face-centered cube. The crystal is effectively one molecule and atom covalent bonds to four others, which in turn bonds to four others, and so on. So we go with Bohr model of atom. And in semiconductor, the atomic structure model by explaining that electrons move in fixed orbital shells and not anywhere in between. And he also explained that each orbit or shell has a fixed energy. Bohr Bohr's model consists of a small nucleus, positively charged, surrounded by a negative electron, moving around the nucleus in orbits. Bohr found that an electron located away from the nucleus has more energy and the electron which is closer to the nucleus energy. So as the Bohr model of an atom, so we can see here there's the Bohr the electron that not move anywhere from the shells, and this is the diagram of it. So next we will move to the extrinsic semiconductor. And extrinsic semiconductors that are doped with specific impurities. The impurity modifies the electrical properties of the semiconductor and makes it more suitable for electronic devices such as diodes and transistors. So there are two types. There are p-type semiconductor and n-type semiconductor. The p-type semiconductor are the fourth atom of the tetravalent atom is free and a hole or vacancy is generated in the trivalent atom. In such materials, the holes are the charge carrier. And the n-type semiconductor is the ionizing energy required to set the fifth electron free is very low, and the electron will become free to move in the lattice of the semiconductor. So that's all that I can present to you about semiconductor. So thank you, and thank you so much.